this Wm of n is equal to En, because if I choose W1 of 2, then it will be equal to E1. So in this way we have taken an arbitrary Wm of n which is equal to En. Now, now we take two sequences, alpha n which is equal to the inner product of x En, and the other one is beta m which is equal to inner product of x and Wm, and we take two terms, one term x1 from this x which is equal to the summation from n is equal to 1 up to infinity alpha n En, and this x2, this one which is from this x, and this is equal to summation m is equal to 1 up to infinity beta m Wm. This is because of our supposition here. According to our supposition, we have rearranged En with Wm, and by definition of this means that there was a bijective mapping from the set of natural numbers onto set of natural numbers, and by definition of this mapping there were two sequences, and these are those two sequences. So we have to prove that their corresponding terms are equal. So it will be enough for us to prove that these two terms x1 and x2 are equal. If we prove that this x1 and x2 are equal, then it will be enough for us to prove this lemma. So now, then by theorem 3.52 and its part B, which was this one, this theorem 3.52 is convergence theorem and its part B, we have this alpha n, this sequence is equal to inner product of x and En, this is equal to the inner product of x1 and En. Similarly, this one beta m, this was equal to the inner product of x Wm. Now by this theorem 3.52 part B, again this inner product of x Wm is equal to the inner product of x2 Wm. Since we had supposed that this En is equal to Wm of n, here we had said Wm of n is equal to En. Now it is just for your note that this is not En, this is E with the subscript n, and which is equal to W with the subscript W of m of n, just like this. This is En, which is equal to W m of n. So now this alpha n is equal to the inner product of x En, which is equal to the inner product of x1 En. So now we write here this inner product x1 minus x2 and En, as this was x1. So now this is again an term x1 minus x2 with the inner product En, which is equal to, by definition of inner product, x1, this x1 with En, and minus this x2 with En. Now why this Wm of n? Due to this, because we have this En is equal to Wm of n, so here we will get En by definition of this inner product, but as En is equal to Wm of n, so we have right here, Wm of n, so which is equal to this inner product of x of En minus x and Wm of n. why why it comes, why this x is here and this x is here? Because here alpha n is was equal to inner product of x En, which was equal to inner product of x1 En. Similarly here, so this x1 En replaces x En, and again here similarly. Now this x with inner product of En minus x and Wm of n, this is equal to 0, because this x is equal to x, this En is equal to Wm of n, so the whole result of this whole term will be equal to 0. And similarly, by using this this beta m, in the case of this beta m, x, if we use x1 minus x2 Wm, then it will be equal to x1 Wm minus x2, and similarly here it will come again Wm of n, so the result will be again, it will be 0. So x1 minus x2 Wm is also equal to 0. Now this norm of x1 minus x2 whole square is equal to this inner product of x1 minus x2 and summation alpha n En minus summation beta m Wm. This is a very well known formula, and it will be discussed in the class also by sir. So by definition of inner product, this is equal to summation alpha n with conjugate inner product of x1 minus x2 En, and again here this minus summation beta m with conjugate inner product of x1 minus x2 Wm, and this whole result is equal to 0. Why this becomes 0? This is due to this. Look at this x1 minus x2 En, and this inner product was equal to 0, and also x1 minus x2 Wm was equal to 0. So when this we will put here 0, this whole term is 0, also this whole term is 0, so the result will be also equal to 0. So it could not be 0. Also this is not 0, these summations. So it means that this x1 minus x2 is equal to 0, and consequently x1 is equal to x2. So as we had supposed that the rearrangement Wm of En, here you can see in the proof this rearrangement En with this rearrangement Wm with En, and by definition we have to take sequences and we have to prove that their corresponding terms are equal. Yes, this. So here we have proved that their corresponding terms, these two were the sequence alpha n and beta m, and we have proved that their terms x1 and x2, these two terms are equal. This completes the proof, and our topic ends with the signature of thanks. Thank you all. I hope you will enjoy. Allah Hafiz.